Okay, let's just try one more of these problems real quick, and I'm just going to do number 4 over here, just to show you again. So let's just kind of run through this. So I've got 2.52 times 10 to the 4th joules of heat. So I'm going to say this is my energy, right? Are added to 2 kilograms. So this is my mass, and here it's mercury. So there's my substance at a final temperature of 130 degrees Celsius. So my T sub F is 130. And they want to know what is my initial temperature, so the T sub I, and again, they give me the substance as mercury. Okay, so I got to go back up and take a look at my chart to get my original for every statement. So there's mercury right over here, and it's 1.4 times 10 to the second, and the units are joules per kilogram degree Celsius, and so I can go back down over here and I can say for every 140 joules, 1 kilogram of mercury changes 1 degree Celsius. Okay, so now I take a look at what was given to me here. Let me just change colors real quick. I'll go back to red here. And I can say for every 25,200 joules, 2 kilograms of mercury changes some number of degrees Celsius, right? And so remember that this value here is my delta T. This is my change in temperature. And I think that's important to remember. It's not a final temperature. It's not an initial temperature. That's my change in temperature. Okay? So the energy went up by a factor of 180. So it gets multiplied by 180. And the mass clearly went up by 2. Right? So it went up by a factor of 2. Okay, so now I can take a look, and I need to know what's the relationship between delta T and energy, because my delta T is what I'm solving for, and what's my relationship between delta T and mass. So I can go back up and take a look because I gave you those relationships. So delta T and mass, you'll notice, is an inverse relationship. Okay, so let's go back and take a look. That's an inverse relationship between delta T and mass. It looks like that, or something like that. And then the relationship between delta T and energy, well, as I add more energy, same amount of mass, the change in temperature goes up. So let's do that one. That one's real easy. So I'm going to say that since the energy went up by a factor of 180, that means that my temperature has to go up by a factor of 180. But since my mass went up by a factor of 2, that means my temperature has to go up by a factor, has to go down by a factor of 2. So I have to divide by 2 there, or do the inverse operation, because I have an inverse graph. And then so instead of multiplying by 180 divided by 2, I can just multiply by 90, right? So the answer is the delta T is 90. Everybody is okay with that, I hope. And so what I can do then is I can go back in, and I know, all right, just erase this. Okay, and then I can say that, okay, well, my delta T is going to be equal to my final temperature minus my initial temperature. If you want to know how much weight you lost, you figure out how much weight you lose now. You figure out how much weight you are there. So you're going to subtract what you are now from what you were before. Okay, so that's just a delta. Anytime you have a change, it's always final minus initial. So I know that my final is 130 degrees Celsius, and I know my change was 90 degrees Celsius, and that's going to be minus the T sub I. I'm sorry, this is a little messy, but okay, so I'm going to subtract over the 130 to get rid of that. Whoop! Negative 40 degrees Celsius is equal to negative T sub I. And so to get rid of the negative for the T sub I, I got to divide both sides by negative 1. And I get 40 degrees Celsius is equal to my T sub I. Okay, so that gives you two representations, one with an inverse relationship, one with a non-inverse relationship, and you can see that we got the right answer there. Okay, I hope that helps. Don't forget we have the math quiz in my class tomorrow. Okay, bye guys.